If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level where we are building concepts on functions. So in this lecture we will see transformation of function, that is vertical shift, vertical and horizontal stretching and compression. How we will do graphically in terms of any function. Okay, then let's see this. Okay, in transformation of function there are vertical in the topic of that is function. So the topic is how we will shift function. If you get fx, then you can do something to get other functions also. You can shift fx, you can stretch it, you can compress it either direction. So these things we will learn here. So if you see, if I take k is a number which is positive, then if it is fx plus k, fx minus k, and there is a difference between these and these. You can see these and these. What is the difference? It is something plus minus. You can think of it is doing with y, that is y equal to fx, you are adding k, and here you are adding with x. So that thing you have to do, think, remember, it is you are directly adding with x. Here you are not adding with x. You can think that you are doing something with y, with the output of fx. Output was y, but here you are doing something with the input. So you can remember it, plus minus. We always remember plus minus. So up down. In up and down we never say down up, we say up down. So plus minus up down. So plus means it will be upward. So if you know the graph of fx, so fx plus k will move up. If you know the graph of fx, fx minus k will move down. K is a positive number. Negative number means automatically you can do it. It is minus 2, so obviously we will think of this. So if it is something negative, then you will come down parallel to y-axis. So the shifting will be always in vertical shift. It will up, down. Here also it is plus minus. You always do left, right. You never do right, left. So it is left, right. So it is plus means it will move left in x direction. If it is minus, it will move right direction. So I have given explained it in this example. Suppose this is your function, original function, any arbitrary function I have taken, y equal to fx. So if it is fx plus k, so it is plus, that's why left. If x minus k, so it is right. So it will be moved k unit from this point. So you can see the identical graph just moved k unit. Here it is same identical graph just moved k unit right side. If it is plus k, fx plus k, it is move up. If it is move fx minus k, it will move down. The same length, the length is k. So it says this much unit, it will move up and down. Now next is reflection on x and y axis. You can see it is the you are doing something on x. So something on x means it will get reflected in y. You are doing something on the output, that means that will be reflection on x. So you can think, because coordinate geometry is just opposite to each other. So if you put a minus on the output, that means you are doing something minus on y, so it will get reflected in x axis. If it is something on the input that is on x, that is it will get reflected in y axis. So if you see, if it is your fx original function, so if you are doing minus x, so it will get reflected in y axis. So if you take a mirror and the reflection of this one, it will just come above this one. If you can fold it, if my figure is correct, it will just fall, this one will fall above it. And what is this is your this one is equal to fx. So what will be minus effect? It will be reflection on axis. If you take mirror, so just a mirror image of this one, the dot 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 one. So this one will be minus fx. Now vertical stretching and compression. Vertical, if you want to stretch it, if you want to compress it. So if you again, you can see you are multiplying with the output. So you are doing something with the output. That's why it is vertical. It will be doing something with the vertical, nothing in horizontal. So if it is k is greater than 1, if I think k is greater than, so if you take product 2, 3, 4, 2.51, so it will be stretched by a factor. You will be stretching it. If you are stretching it 2 times. If you are divide, then you are compressing it here. So it will be compressed by a factor of k in the vertical direction. So you can see this is your original graph, the middle one, y equal to fx. So if you do y equal to k fx, that means you are multiplying your output. So output get increased. So it is, that means something of this fashion. This is rubber band. You have stressed it. You have stressed it this side. So it is get elongated. And if you are dividing by k is obviously greater than 1. I am not thinking of fraction. If it is half, then you can think it is k is 2. No issue. So if you divide it by k, then it is compressing. You are compressing. You are pressing this side, this side. The entire graph is compressed. So the inside one, so it gets shortened. So it is 1 by k fx. Now while horizontal stretching and compression same, then you will multiply with x. This is multiplying, this is divide. But here it is little bit different with your vertical. If you multiply with this one, it will get compressed. Earlier in vertical, if you multiply with a k which is greater than 1, it was elongated. stressed, but here it will be compressed in x. If you multiply by k, it will get compressed. If you divide it by k, then it will get elongated or it will stretch. One example I have taken, fx equal to say sin x. So you know the graph of sin x. What will be sin 2x? That means f of kx, so it will get stretched. You can see the dotted one is the stretched button. You stretched it, you just zoomed it, you just zoom out it, so it get compressed. Because you can see if you put pi by 2, it will be sin pi, so the value will be 0. So that's why earlier 0 was coming here, and if you put x equal to pi, but here if you put x equal to pi by 2, it will be 0. So it is compressed. And here if you see, if you divide by 2, so this is your fx, now it is get elongated. So this is sin x, this one, and this shaded one is the sin x by 2. Now if you put 2 pi, then only it will getting 0. So it is getting stressed now. So you can think the time period here getting reduced. So one cycle coming very fast, here time period get reduced. So you can think of in terms of time period. Here time period, original sin x time period was 2 pi, here time period will get reduced because it is compressed. Here time period will get multiplied by 2 because you are multiplying by 2. So you can think in this way also. One extra I have given to show you what is the idea of mod. I have explained it in advance also while solving differentiability. This is your fx sin x. If you take mod, this negative portion will get reflected. So this will obviously there, and in mod x this will also come instead of this. So that shaded one dot dot dot, this shaded one is the graph of y equal to mod sin x. And sin x, you know, this is the curve of sin x. So the negative portion just get reflected in the x-axis. If you like the video, then press the like button and please give your valuable comments in the comment section.